From super tanks capable of withstanding all types of ammunition, to stealth drones that can infiltrate deep into enemy territory undetected. Are you ready to witness this incredible military might? Let's begin our journey of discovery right now. 10. Sikorsky Raider X. The Sikorski Raider X is a concept helicopter featuring coaxial rotors and a single pusher propeller, designed by the Sikorsky Aircraft Division of Lockheed Martin. The Raider X concept was unveiled in October 2019. In March 2020, the Army selected the Raider X and the Bell 360 Invictus from a list of 5 design concept candidates. The concept models of the Raider X and the 360 Invictus were to be built as flying prototypes for a competition scheduled for 2023. However, the FARA program was cancelled in 2024. Contracts were awarded in April 2019 to develop design concept candidates for the FARA program. 5 different teams were selected, including Sikorsky. Sikorsky unveiled the Raider X design concept at the Association of the United States Army's annual meeting on October 14, 2019. The Raider X concept originates from the earlier Sikorsky S-97 Raider, which was developed for the Army's Armed Aerial Scout program. The S-97 itself was developed from the Sikorsky X-2 compound coaxial helicopter prototype. A larger Sikorsky, Boeing SB-1 Defiant, also derived from the X-2, is being developed under the Army's Future Vertical Lift program to create a new class of multi-role helicopters. The SB-1 is a candidate for the Future Long-Range Assault Aircraft program. Sikorsky's compound helicopter designs all use rigid coaxial rotors and a pusher propeller, collectively referred to by Sikorsky as EX-2 technology. The Raider X program was initiated in April 2024, but Sikorsky has no plans for flight tests. The Raider X, in accordance with the FARA program specifications, is designed to use a single General Electric T901 engine. The GE-T901 is developed under the Army's Improved Turbine Engine Program, ITEP, as the new engine for current and future Army helicopters. Based on the performance of the S-97 and X-2, the Raider X is expected to have a maximum speed exceeding 250 knots with a service ceiling greater than 9,000 feet. Sikorsky considers the S-97 to be an 80% scale model of the Raider X. The Raider X is expected to weigh 14,000 pounds. Swift Engineering will design and manufacture the airframe. The cockpit features side-by-side seating instead of the tandem seating typical of American attack helicopters. Weapons and sensors are mounted internally using a modular system, in line with FARA specifications, to accommodate future upgrades and obsolescence. 9. M1150 Assault Breacher Vehicle. The M1150 is a highly mobile armored breaching vehicle based on the M1 Abrams tank chassis. The M1150 Assault Breacher Vehicle combines elements of a tank and a mine-clearing device, prioritizing crew safety and vehicle survivability, while maintaining necessary speed and agility to synchronize with maneuver forces. The ABV serves in the U.S. Army as part of the Heavy Brigade Combat Team. It is also part of the Army National Guard, Army Reserve, and Army's Logistics Reserve. Developed by the U.S. Department of Defense, the ABV entered service in 2009. U.S. Marines used the M1150 in Helmand Province, Afghanistan, during a campaign in December 2009. They ceased using these vehicles in 2023. In November 2023, an M1150 ABV was displayed in Ukraine as part of the celebration for Ukraine's Missile and Artillery Forces and Engineering Troops Day. A total of 239 M1150 ABVs were produced by November 2023. The M1150 ABV integrates the hull of the M1A1 Abrams tank and a specialized turret housing 2 linear demolition charge launch systems with rocket-propelled mine-clearing lines. Additionally, it includes a lane marking system, integrated observation systems, and an enhanced conversion kit that can be used to mount a wide-area mine plow or combat dozer blade. The vehicle is 12 meters long, weighs 72 tons, and can accommodate a crew of 2 members. A unique 4.6-meter wide mine plow mounted at the front of the vehicle is reinforced with metal skis that slide along the ground when the vehicle moves forward. It establishes a tank-width path through minefields by deploying and detonating one of its Miclic systems across the minefield. The vehicle reinforces the path using its FWMP and designates the cleared route with its LMS. The ABV is equipped with DRS-IVS, an advanced thermal observation technology. The IVS integrates advanced uncooled thermal technology into a compact, dual-axis stabilized gimbal, along with DRS-enhanced situational awareness camera system. The vehicle is equipped with 2 M58 Miclic launchers to remotely clear mines. The launchers can create a cleared path up to 100 meters long and 8 meters wide through minefields. The crew can use the M2 Browning machine gun for self-defense. The M1150 is powered by a 1,500 horsepower engine. The M1150 assault breacher vehicle is manufactured at the Anniston Army Depot in Anniston, Alabama, USA, with engineering violation systems provided by Pearson Engineering, a civil engineering company based in the UK. AECOM, a US-based engineering company, provides the linear demolition charge launching systems for the vehicle, while Leonardo DRS, a US-based defense industry company, supplies the thermal IVS system and embedded diagnostic system. 8.M1074 Joint Assault Bridge. The M1074 Joint Assault Bridge is a steel-armored military engineering vehicle of the United States, based on the chassis of the M1A1 Abrams main battle tank. Leonardo DRS designed the M1074 for the U.S. Army and Marine Corps to provide bridge deployment capabilities for military operations. The Joint Assault Bridge is a military engineering vehicle that deploys a scissors-type bridge from a steel-armored vehicle. The military load class 95 JAB is currently being replaced by the heavy assault bridge MLC 115 JAB. After the M1074 deploys the bridge, combat vehicles can cross over it. The M1074 can then retrieve the bridge from the far bank and continue supporting advancing forces. The M1074 Joint Assault Bridge weighs 68.7 short tons and is 32.25 feet long when deployed with the bridge. Its width is 12 feet, and its height reaches 5.6 feet without the bridge and 10.1 feet with the bridge. The M1074 is not equipped with primary or secondary weapons. Its engine is a multi-fuel Honeywell AGT 1500 gas turbine engine, generating 1,500 shaft horsepower. The vehicle has a power-to-weight ratio of 23.8 horsepower per ton. The MLC 115 folding bridge system of the heavy assault bridge is controlled by switches and transmission processes using an Allison DDA X-1100-3B gearbox with 4 forward gears and 2 reverse gears. The HASB uses high-strength steel torsion bars with rotating shock absorbers and can clear a span of 0.48 meters. The M1074's chassis is based on the M1A1 Abrams main battle tank, using the suspension system from the M1A2 and upgraded with an integrated full power pack recovery system. The M1074 Joint Assault Bridge unit features a new hydraulic bridge launch system and embedded diagnostics. Survivability is enhanced with components from the Urban Survival Toolkit of the tank, including Abrams reactive armor tiles, rear observation sensor system, and tank infantry phone. Additionally, it can use the auto-flug driver seat and Abrams light undercarriage for use in situations. The M1074 Joint Assault Bridge itself does not have weapons. However, crew members are typically equipped with assault rifles, signal pistols, and/or smoke grenades. The vehicle can hold 500 gallons of U.S. fuel and has an operational range of up to 260 miles. Its maximum speed on roads is 45 miles per hour, and in difficult terrain, it is 30 miles per hour. As of 2016, 51 M1074 Joint Assault Bridge vehicles had been built, with plans to ramp up full-scale production starting in 2019. 7. Jobaria Defense Systems. The multiple launcher of the Jobaria defense system, also known as the Jahannam launcher, is a multi-barrel rocket launcher manufactured by the UAE specifically for the United Arab Emirates Army. It has 240 launch tubes, making it the world's largest rocket artillery in terms of the number of launch tubes. It is said to function as a combined form of the BM-21 Grad multiple rocket launcher. It was developed by the Al Jaber Land Systems joint venture. The United Arab Emirates Army requested mounting a rocket artillery battery on one vehicle, as the Army was using 6 vehicles, likely BM-21 Grads, and 30 soldiers to do so. Due to the small number of personnel in the United Arab Emirates Army, the multiple launch system has an advantage over using 6 vehicles requiring a team of 30 people, while the multiple launch system only needs a team of 3 to operate and launch the same number of rockets. The system has 4 rocket launchers mounted on a tractor, each carrying 6,122mm rockets. This system fires Roketsan 122mm T-122 Sikorski rockets equipped with high explosive warheads that can be detonated using point detonating or proximity fuses. The system operator can choose the number and type of warheads to fire. All rockets can be fired in less than 2 minutes, giving a firing rate of 2 rounds per second. After launching rockets, the system can move and continue firing rockets if it hasn't launched its entire payload, or if it has, it can be rearmed by a support vehicle in about 30 minutes. Roketsan has also developed a rocket launcher capable of firing both 107mm and 122mm rockets from the same launcher, making it a multi-caliber rocket launcher. In February 2017, Al Jaber revealed the Jobaria Twin Cradle Launcher Heavy Rocket Artillery System. Based on the multiple rocket launcher, it fires 300mm rockets from 2 4-rocket launchers. The system can fire either the Turkish T-300 Kasirga from a range of 30 to 120 kilometers. The TCL has a reduced trailer length of 21 m. 6. Caspian Sea Monster. The Korabel Maket, commonly known as the Caspian Sea Monster, was a ground-effect vehicle test craft developed in the Soviet Union in the 1960s by the Central Hydrofoil Design Bureau. The KM began operations in 1966 and was continuously tested by the Soviet Navy until 1980, when it crashed into the Caspian Sea. The KM was the world's largest and heaviest aircraft from 1966 to 1988, and its unexpected discovery by the United States, along with subsequent efforts to determine its purpose, became a notable espionage event during the Cold War. The KM was an experimental aircraft developed from 1964 to 1966, during a period when the Soviet Union was interested in ground-effect vehicles, aircraft-like vehicles that use ground effect to fly a few meters above the surface, primarily water. It was designed at the Central Hydrofoil Design Bureau by Chief Designer Rostislav Alexeyev and Chief Engineer V. Efimov, and was manufactured at the Red Sormovo factory in Gorky. The KM was one of the earliest and largest Ekranoplan projects, notable for its enormous size and payload capacity, becoming the world's largest aircraft when completed in 1966. The KM had a wingspan of 37.6 meters, a length of 92 m, a maximum takeoff weight of 544 tons, and was designed to fly at an altitude of 5 to 10 meters to utilize ground effect. This aircraft had 10 Dobrinin RD-7 jet engines, with 2 engines mounted on the tail and 8 engines mounted on the nose wing. The 8 nose-mounted engines would shut off after takeoff, leaving the 2 tail-mounted engines to power the aircraft during normal transit. The KM could not be detected by many radar systems because it flew below the minimum detection altitude. Although technically an aircraft, it was considered by authorities to be more like a boat and was assigned to the Soviet Navy, but operated by Soviet Air Force test pilots. The KM was registered as a sea vessel, and before its first flight, a bottle of champagne was broken against its bow, a tradition for a ship's maiden voyage. You have seen the first 5 vehicles already. Impressive, right? But that's just half of it. The remaining 5 vehicles are even more incredible. If you like this video, don't forget to like and subscribe to our channel. Comment below to let us know what you think about them. Now, let's continue exploring the remaining 5 vehicles. They will leave you in awe. 5. M3 Amphibious Rig. The M3 Amphibious Rig is a self-propelled transport and amphibious landing vehicle used to launch tanks and other vehicles across water obstacles. Initially developed by the German company Eisenwerk Kaiserslautern, it succeeded the conceptually similar M2 vehicle produced by the same company. Like its predecessor, the M3 moves on roads using 4 wheels and floats on water using 2 large aluminum pontoons. The development of the M3 began in 1982, with the final prototype delivered 10 years later in 1992. The first order of 64 mass-produced vehicles was placed in 1994, and it was put into service in the German and British armies in 1996. Since then, the M3 has also been adopted by several NATO and Allied countries. The M3 can self-deploy on roads, operating as a 4-wheeled vehicle with a maximum road speed of 80 km per hour. For amphibious operations, 2 large aluminum pontoons are deployed, extending them along the length of the vehicle. The crew exits the vehicle cabin to operate the pontoons using controls located on the vehicle body. In water, the M3 is propelled and steered by 2 fully maneuverable pump jets at speeds of up to 14 km per hour. Multiple rigs can be connected together using long connectors called E-ramps, 4 of which are carried on each vehicle, to form a bridge across a water obstacle. 8 M3 rigs can span a 100-meter water distance this way, allowing vehicles with loads up to 60 tons or more, such as the Leopard 2A6 and Challenger 2, to cross. Additionally, just 2 rigs can be connected to form a ferry capable of carrying a similar load across much wider water distances. The M3 Amphibious Rig saw its first combat operations during Operation Telic, the British military operation in the Iraq War. From March 25, 2003, the 23 Amphibious Engineer Squadron, part of the 28 Engineer Regiment of the Royal Engineers, transported elements of the 3 Commando Brigade across the Shat al-Basra waterway, allowing them to advance into the city of Basra, Iraq. A subsequent river crossing at the Rumaila oil field was also conducted using the M3. This action transported 3 AS-90 self-propelled guns in support of the British Army's 16 Air Assault Brigade. 4. BVS10 Viking. The BVS-10 is an amphibious all-terrain armored vehicle manufactured by BAE Systems Land Systems Hägglunds of Sweden. This vehicle, known in the UK as the All-Terrain Vehicle or Viking, was initially developed through a collaboration between industry, Hägglunds Vehicle AB, and the UK Ministry of Defence on behalf of the Royal Marines. The BVS-10 is similar but distinct from Hägglunds' earlier models like the Bandvagn 206 or Boulevard 206S. This is a significantly larger vehicle based on Hägglunds' articulated steering frame system and characteristic twin-cabin design. The vehicle consists of 2 linked sections connected by an articulated joint. The front compartment weighs 5,000 kilograms, while the rear weighs 3,500 kilograms. It is powered by a Cummins turbocharged diesel engine producing 285 horsepower. Its maximum speed on highways is 65 to 70 kilometers per hour. These specially armored vehicles can traverse water obstacles by swimming at a speed of 5 kilometers per hour. It has a fuel reserve for a range of 500 kilometers. The troop compartment can accommodate up to 12 people. In terms of weaponry, the BVS-10 Viking can be equipped with several types of machine guns, including the Browning M2 12.7mm or the Mark 1940mm automatic grenade launcher. There is a dedicated smoke grenade launcher at the front of the cabin. The basic version of the armored protection can shield infantry from 7.62mm bullets and shell fragments. It can also be enhanced, for instance, by adding additional armor plates or external steel cages. Notably, the rear articulated joint of the BVS-10 Viking can serve as a platform to carry various types of weapons, such as artillery guns or anti-aircraft missiles. On the other side of the battlefront, the Russian military also employs several types of tracked articulated vehicles, including armored vehicles. They are capable of conducting combat missions in almost any terrain. The 38th Marine Corps Brigade of the Armed Forces of Ukraine has received nearly 40 articulated tracked armored personnel carriers, including the BVS-10 Viking, provided by Sweden. These armored personnel carriers have arrived from the Netherlands to the hotspot E. Currently, they are positioned far from the front lines and appear to be intended for use during thaw periods, given their high mobility capabilities. The BVS10 Viking was originally manufactured in Sweden under a contract for the British Royal Marines. The design incorporates experience from the development and operation of the non-armored BV206 model. 3. Keeler. The Keeler mine clearance vehicle was developed and produced by Rheinmetall Defense. From 1996 to 1998, a total of 24 Keeler vehicles were delivered to the German military. The Keeler weighs 53 tons, with dimensions of 8.95 meters in length, 3.76 meters in width, and 3.8 meters in height. It is powered by a turbocharged MTU MB871 Ka 501 engine, providing 986 horsepower in travel mode and 1,092 horsepower in mine clearance mode. The Keeler can travel at a maximum road speed of 48 km per hour and has a range of 350 km. The Keeler is operated by a crew of 2. This vehicle is designed on the chassis and hull of the M48 Patton A2C main battle tank. The original turret of the M48 has been removed and replaced with a mine clearance system consisting of a dozer blade, roller, and mine rake. The mine plow is used for digging and clearing, while the roller is used to detonate mines by exerting pressure on them. The Keeler also features a remotely controlled arm that can be used to safely detonate mines from a distance. Additionally, the vehicle is equipped with sensors and advanced communication systems, allowing it to detect, identify, and handle mines and other explosive devices. This mine clearance vehicle can clear a path 4.7 meters wide and 120 meters long in a minefield within 15 minutes. To achieve this, it uses 24 mine rakes to clear at depths ranging from +50 to -250 millimeters. When clearing the surface at +50 millimeters depth, the vehicle travels at a speed of 4 kilometers per hour. As it clears deeper, the speed decreases to 2 kilometers per hour. 2. Zuber class hovercraft. The Zuber class, known in the Soviet Union as Project 1232.2, is an air-cushioned landing craft designed by the Soviet Union. Żubr is Russian for the European bison, or European bison. As of 2023, this military air-cushioned craft is the largest in the world, with a standard fully loaded displacement of 555 tons. The air-cushioned craft is designed to transport assault units from equipped or unequipped ships to non-equipped coastlines, as well as to transport and deploy naval mines. 10 Zuber-class hovercraft are still in operation. There are 2 vessels in the Russian Navy and 4 in the Hellenic Navy. In 2009, China purchased 4 hovercraft from Ukraine as part of a deal worth $315 million. 2 upgraded versions of the craft were constructed by the Feodosia Shipbuilding Company in Crimea, followed by 2 more advanced surface combat craft. In 2023, an additional 2 craft were built and modernized, both numbered 3260 and 3261. With a length of 57 meters and a width of 25.6 meters, the Zuber-class hovercraft can operate effectively on water, on land, and in harsh climatic conditions. Equipped with powerful engines, the vessel can reach a maximum speed of 63 knots and maintain a speed of 55 knots for extended periods. The armament on the Zuber-class hovercraft is also notable, including air defense missile systems, the AK-6 30mm close-range weapon system, and the capability to launch rockets via the Ogon 140mm launcher. Additionally, the ship can use mines with a detachable equipment system capable of laying between 20 to 80 mines, depending on the type of mine. Equipped with modern sensors and processing systems such as the Ekran 1 navigation radar and the R782 Buran communication system, the Zuber-class hovercraft is an indispensable part of the fleet, capable of operating flexibly and effectively in diverse maritime missions. 1. Ultra-Heavy Lift Amphibious Connector. The Captive Air Amphibious Transporter is a prototype water-crossing vehicle with a 1:5 track ratio currently under development by DARPA. It travels on the water using air-filled pontoons attached to a track system, designed to demonstrate the transportation of standard 20 or 40-foot containers from conventional container ships to shore without the need for a port. DARPA is researching its utility in disaster scenarios to facilitate commercial transport, which could allow military vessels to focus on military missions. CAAT is one of the 4 components of the Strategic Mobility and Agile Response to Threats program. The Marine Corps Combat Development Laboratory is using CAAT's air-filled pontoon track system in the concept of the Superlift Amphibious Connector. The goal is to develop a new amphibious connector vehicle to transport vehicles of the U.S. Marine Corps from the ship to another shore with heavier payloads and to overcome obstacles on land. It has a length of 42 feet, width of 26 feet, height of 17 feet, weighs 38 tons, and moves at a speed of 4 to 5 nautical miles on water. The hull is made of aluminum, with a small cockpit attached at the bow. It uses tracked feet equipped with dense air-filled foam blocks to float on water and propel it on land, allowing it to pass through mud, sand, and marshy areas when approaching the shore. This results in a ground pressure of about 1 psi, compared to 9.7 psi for amphibious assault vehicles. The full-size UHAC is planned to be 84 feet long and up to 34 feet high. UHAC is planned to have a heavier payload capacity ranging from 150 tons to 190 tons compared to 65 tons, with a longer operational range beyond 200 nautical miles compared to 86 nautical miles. It benefits from using tracks to move onto land from beaches and over 10-foot-high seawalls, and estimated construction and maintenance costs per unit are less than half. LCAC has a higher surface speed of over 30 knots compared to UHAC's 20 knots and a smaller footprint of 1,800 square feet versus 2,500 square feet for UHAC. UHAC will move faster on water than AAVs, and can even transport them closer to shore or carry up to 3 M1 Abrams tanks. The production version will be designed to withstand lower configurations of armor and weaponry. The concept of UHAC began in 2008 with the goal of designing a low PSI amphibious vehicle. The Office of Naval Research accepted Navitec's design, and 3 prototypes have been built since then. Currently, UHAC's efforts involve collaboration between the U.S. Office of Naval Research and Singapore's Ministry of Defence's Science and Technology. No decisions have been made yet regarding the final steps needed to produce a full-scale version. So we've covered the top 10 most incredible military vehicles in the world. Each vehicle showcases the power of modern military technology. But this is just the tip of the iceberg. In the next video, we'll delve deeper into a more specific area: the top 10 most powerful self-propelled artillery in the world. These mobile artillery pieces can change the battlefield dynamics in an instant. Stay tuned to find out which artillery will top the list. If you enjoyed this video, don't forget to like, share, and subscribe to our channel so you don't miss out on upcoming exciting content. See you in the next video.